Orthogonal vectors means two vectors are perpendicular to each other. So to prove that two vectors are orthogonal, you have to prove that the dot product is equals to 0. But why 0? So here is why. The angle between two vectors is this formula. So it can be computed by this formula. Cosine of theta equals to the dot product divided by the product of the magnitude. So when the product is equals to 0, it doesn't matter what the magnitude is, 0 divided by non-zero is equals to 0. So that you have cosine of something equals to 0. And then the only answer for theta is cosine of pi over 2 is equals to 0. So what is pi over 2 in degree? Pi over 2 in degree is 90 degree. That is why. So you have to make the numerator equals to 0. So I have two vectors, A and B. Are they orthogonal? Let's find out. So we have vector A times vector B dot product, so which is 0 times 8 plus 5 times 0 times 0. So the dot product is equals to 0. So now pretty much they are two orthogonal vectors. Let's do the magnitude anyway. So we have magnitude of vector A that is equals to the square root of 0 squared plus 5 squared. Of course, that returns to 5. And then the magnitude of vector B, that is the square root of 8 squared plus 0 squared. That is equals to 8, and then you put everything together, you have cosine of theta equals to the dot product divided by the product of the magnitude, 5 times 8, that is equals to 0. So we know that cosine of pi over 2 is equals to 0, and then pi over 2 is equals to 90 degrees. So the answer is yes, these two vectors are orthogonal. So as long as you have that, then you can prove that these two vectors are orthogonal. Let's try another problem, and then I will do the green one. So let's pick a different color. So we try another problem. How about let's try I, j, and k. So we have vector A equals to 2i minus 3j plus 4k, and then vector B equals to 5i plus 6j plus 2k. Are they orthogonal? Let's check the dot product. So we have A dot B, of course they are in vector, 2 times 5 plus negative 3 times 6 plus 4 times 2. So we have the dot product equals to 0. And then we have a magnitude of is already equals to 0. So now pretty much I can say that they are orthogonal. But since we have the formula, I would like to do the magnitude as well. We already know the answer, but let's complete the job. This is the square root of each component, right? So 2 squared plus negative 3 squared plus 4 squared, that is equals to the square root of 29. And then vector B, square each components, add the square up, 5 squared plus 6 squared plus 2 squared. This is equals to square root of 65. And then you put everything into the formula. You have cosine of theta equals to the dot product divided by the product of the magnitude, root 29, root 65, this is equals to 0. So the only answer is cosine of pi over 2 equals to 0, and pi over 2 is 90 degrees. So these two vectors are orthogonal. So let's try something that is harder. The next problem is hard, it's long. Find a unit vector that is orthogonal to both vector I plus j and I plus k. How do we do this? Find a unit vector. So what is a unit vector? So here is the unit vector. We start with the unit vector, which is vector A. I will just call this A1 times I plus A2 times j plus A3 times k. And then this unit vector must orthogonal. Let me put it right here, orthogonal to I plus j and I plus k, right? I plus j and I plus k. I am looking for the components A1, A2, and A3. Okay, so since they are orthogonal, so that means when I take vector A, multiply I plus j, when I consider the dot product must be 0. So when we take vector A and then you multiply I plus j, so this must be equals to 0. So vector A times I plus j, then I plus j, then we will be using A1 time A1 plus A2 equals to 0. Because the number in front of I is 1, the number in front of j is 1, so we will, since there is no k, then we will just use A1 plus A2. So we have A1 times 1 plus A2 times 1 equals to 0. If there is a ij plus k, then that will be A1 plus A2 plus A3 equals to 0. And then this one we can set A1 equals to negative A2. And then how about I plus k? Then we have vector A times I plus k equals to 0. And then we have vector A times I. Oh, no. Okay, I and k, so this will be A1 and A3. So we have A1 plus A3 equals to 0. Then A1 is equals to negative A3. A3. So now, do you see that we have A1 equals to negative A2, and in the meantime, A1 is also equals to negative A3. So now, pretty much we can say this. We can say we can set negative A2 and A3 together. So negative A2 is equals to negative A3 because they are both what A1 belongs to, what A1 equals to, and then in the meantime, that is equals to A1. So this is pretty much the first step of the answer. And then we continue. So what is a unit vector? Unit vector means the magnitude is equals to 1. So we have vector A is a unit vector that tells me that the magnitude is equals to 1. How do you write that? So we have magnitude of vector A that is equals to the square of A1 square plus A2 square plus A3 square. The magnitude is equals to 1. When you square both sides, you have A1 square plus A2 square plus A3 square equals to 1. Now, I am going to recall this. Let me switch to a different color. I am going to recall this. So I'm going to recall. It is good to write this line again. Negative A2 equals to negative A3, which is equals to A1. All right, and then you are going to do some algebra. So A1, we are not going to change A1, so A1 stays as a A1. And then A2, when A2 is positive, do we agree that that is equals to negative A1? So A2 is equals to A1. Here. A2. So A2 is equals to negative A1. And then when you square both sides, do you see the right hand side? When you square both sides, this negative will be cancelled. So basically we have A2 is just A1 square. Same thing for A3. Because when you square both sides, once again, you have, look, you have negative A2 equals to A1, right? So that means A2 is equals to negative A1. I just multiply both sides by negative. So negative A2 equals to A1. That means A2 itself is equals to negative A1. And then when I square both sides, this negative symbol becomes positive. So we have A1 square plus A1 square, and then this is a little mistake, plus A1 square equals to 1. So you have to do an algebra like that. Then this is a 3 times A1 square equals to 1. Now we get one of them. So we have A1 square equals to 1/3. And then when you take the square root on both sides, since square is even, then A1 is equals to plus or minus. Take the square root on both sides, then you have 1 divided by root 3. And then there are two unit vectors. When A1 is equals to that, so when A1 is equals to the positive, and then how about A2 and A3? When A1 is equals to that, so when A1 is equals to that, then A2 and A3 has a negative in front. Look at the red line, the line that I recall. So you have a negative of this, and then a negative of this. This is the first unit vector. I will put everything in in a vector. And then also, when A1 is negative, you have A2 and then A3. All right? So when A1 is negative, so when this A1 is negative, do we agree that to make this A1 negative, look at the red line, when this A1 is negative, I have to multiply the entire thing by -1. So when you do so, this becomes positive, this becomes positive. So you have a positive this, and then positive this. So finally, you have two unit vectors. The first one is vector A equals to the first line I, and then minus j, and then minus k. And then the second one, we have vector A equals to -1 over square root of 3i, and then these two are positive. So these two, they are unit vectors. The magnitude is equals to 1. All right, so that is the end of this video. If you like the way I explain orthogonal vectors, if you think I put a good problem for discussion, give this video a thumbs up. If this is what you wanted to see, give my channel a subscribe. Trust me, it is worthwhile coming back to visit more math content. As always, I will meet you all in the next lesson. Signing out.